Law of cosines. Oh yeah, let me write down for the recording the law of cosines. So what was it again? So with a triangle where this is A, B, C, and little a is across from A, and little c is across from C, and little b is across from B. The law of cosine says c squared, that's supposed to be a little c, c squared is a squared plus b squared minus 2ab cosine capital C, or the other two ways of writing it, b squared is a squared plus c squared minus 2ac cosine of the one across from it, b. It's always that one across from it at the end, isn't it? So whatever you start with, you finish with that same letter. So if you start with a, it's the other two, b squared plus c squared, minus 2 times those two times the cosine of the one you started with, a. So there we go. There's the law of cosines. All right, so, and as we do this, remember, A is across from A, B is across from B, C is across from C. That's how they always, that's just the naming scheme for the triangles that we deal with. All right, getting back to the problem. So here's number 1. So first off, you know what I always want to do is I always want to stop and say, why do we need a new formula? I want you to see the reason, so it isn't just like, hey, it's the next thing we got to do. Remember, what we're trying to do here is become masters, like really good masters. You will be, and you are almost are at this point, of triangles. Like you can do anything with a triangle. So, okay, so why do we need a new skill? What if somebody said, hey, solve that triangle, and we didn't have the law of cosines? Could we do it based on what we already have? Actually, no. Let me help you see that. Do you see, we couldn't do this one without the new information. Why not? Well, why don't we try? First off, it's not a 90-degree triangle. It's not a right triangle, so we can't use any of the SOHCAHTOA, right? No SOHCAHTOA, right? Because that always involves hypotenuses, and that means you got a right angle, and we don't have a right angle. That's the whole thing that's new about Chapter 4. We talked about that last time. It's not a right triangle. We're breaking away. We're wanting to learn how to handle triangles that aren't simple right triangles. That everything we did in the first 3 chapters was all right triangles. So now, how do you handle a triangle that's not a right triangle? You can't do SOHCAHTOA. Okay, well, what about law of sines? That's why we learned law of sines last time. Why doesn't that just handle everything? Well, let's try law of sines and see it won't get us anywhere for the particular way this triangle's set up. The trick is they gave us an angle between 2 sides. They didn't do that in last night's homework because you can't use law of sines when they do that. Let me show you. So if you tried to do law of sines, how does law of sines work? Remember law of sines? It was just last night's homework. Law of sines, remember that one? That was little a over sine A is little b over sine b is little c over sine c, right? And you use any 2 fractions you want thereof. Okay, so what would I say? How about this angle with this side? Okay, so that would be little a over sine 45 equals, right? Remember they come in ratios, right? Angle inside across from it. That's law of sines. Angle inside across from it. Equal, now what other 2 do you want to use? I could do b with the angle here, which is b, So that would be little b, which is 5, over the sine of angle b, right? Can we solve that?
No.
No, why not?
Because you don't know what a is.
Yeah, we have 2 letters.
You have to know what corresponding letters
You can only have 1 letter, not 2.
Mm-hmm.
Right? That's like me saying, hey, x equals 3y plus 7. Find x and y. Well, I can't do that. You got to give me y or give me x or something. I can't have 2 letters and somehow find numbers for everything. No way. Do you see the problem? Do you see why? Because there's no complete ratio there. You know what they call this? I don't know if you remember anything from geometry at all. I didn't learn anything about in geometry in high school. But side, angle, side, this is called. This S, yeah, side, angle, side. If they give you, meaning it's 2 sides and the angle in between, they call that side, angle, side information. If you look at the book, if you click on the textbook on the Math Excel, even it'll talk about side angle, side information. So this is, I'm not going to quiz you on that, but this is side angle, side information, meaning they're giving me an angle in between two sides. So what? Well, that means I have no complete ratio and can't use the law of sines. It just won't get me anywhere. Do you see? I never have a complete set. I never have an angle and the side across. I have this angle, but not the side across. I have this side, but not the angle across. I have this side, but not the angle across. I have no complete fraction. So I can't use the law of sines. There's just no way to do it. You're always going to have two letters. And if you do, well, do the C. If I did the C, it'd be the same thing. It'd be 8 over the sine of C. See, all of them have a letter, a letter, a letter. We have to have two numbers and only one letter, to use law of sines, and we don't have that. All right, so that's why we can't use law of sines. That's why we need something new, law of cosines. All right, so let's do it. Law of cosines, that's why they invented it. And, all right, so how's it going to work? Basically, it says you can use any of three of those. So what side? I can't find the angles right now, right? Because there's two missing angles. Remember how if we have two angles, if I knew this was something like, 40 degrees, then I could easily find the other angle because the total is 180. But I don't, so I can't. So I'm not going to do angles first. I'm going to do sides. So I'm going to want to find side A. It's the only side I don't know. I know the other two sides. So how do I find side A? Well, there it is. Pythagorean, the law of cosines. So it's like the Pythagorean, though. It's A squared is B squared plus C squared. So you start with the side you want. So that's how I knew which version to do. I'm saying, well, I want A. So I'll start with A. So you write it out like the Pythagorean, right? A squared is the other two sides squared added up minus, then you put the little adjustment on there. 2BC, remember what it is? It's 2 times those two that are on your side times the cosine of what? Yeah, whatever you started with, that goes here, capital A, angle A. There we go. So there's the law of cosines. You'll have that on your 3x5 card. So A squared then will equal B squared. That's 5 squared plus C squared. That's 8 squared minus 2 times 5 times 8 times cosine of, 45 degrees, angle A. So now we just work it out on our calculator. So make sure you're in degree mode and just type all that stuff in. I'm going to do it too. I'm getting 32.431. And then we got to root it, huh? Am I in the right mode? Am I in degree mode? Yeah, I am. Okay. So then square root it. At the end, it's got to be square rooted because you want A, not A squared. So you can just, you know how to use the answer button on your calculator. Make it as easy for you as possible, right? Just leave the 32. Excuse me. You guys know how to do all that? You leave the 32 and then just go square root of the answer. I'm getting 5.69. I don't know how many. Well, I'm going to use, remember, I always use a lot of accuracy, that at the end I'll round back wherever they want me to. So 5.695. So I got A. Is that coming out okay for you?
No.
No.
So when you put it in, did you put it all in together?
I did, yeah. So I just typed in 5 squared plus 8 squared minus 2 times 5 times 8 cosine 45.
And I got 80 minus the root of 40 something.
Yeah?
I put,
Yeah.
You got what I got, or you got what, maybe I'm messing up.
I did the squaring and added like separately, and then I put minus, and then I put all the multiplication like in parentheses. And I got what you got.
Okay.
Yeah, I'm getting it again. So what I'm doing here is actually correct. Yeah, let me finish it up. I'm not being very clear. Let's finish it up, and then I'll talk about why. This is actually right. This will work perfectly. And I'll show you why. You actually want to start with the 5, not the 8. I'll show you why in a minute. Let's just keep moving along. So we're doing it perfect. What we're doing will work great. So after law of cosines, I'm going to write out some steps really clearly in a minute. After law of cosines for the first step, then you dive into law of sines. Law of sines always matches up sides and the angles across from them. Here we go. So we're going to I set up A over A. A over sine A is B over sine B. Now we can solve. You know what to do. We cross multiply, right? Diagonal, diagonal. I get 5.695. 5.695. Sine B is 5 sine 45. And then how do we solve there for B?
Divide by the 5.6.
Divide, exactly. Divide by that 5.695.
And we have to do sine inverse, right?
Yeah, and then in a minute we'll have to sine inverse. So divide these, and then you'll get sine B equals, and then whatever, let's see, 5 sine 45. Oh, it's some weird mode. Okay. 5 sine 45 divided by 5.695. Okay, I'm getting a 0.6208. Y'all getting that so far? And now we need to find angle B. How do we find angle B? What's the last step?
Sine inverse.
Sine inverse, right? So just leave that on your screen and just use the answer button. So I'm going to go, okay, here we go. Sine inverse. Sine inverse on both sides, like that. These cancel. And B will equal whatever. Sine inverse of your answer, huh?
Yeah, 38.376.
Yeah, so I'm getting to 38 point, yeah, I'll just say 376 degrees. That's the degrees, huh? Yeah, just use a few places. We'll round in the end. So that's angle B. Don't worry about finding another sine option. It doesn't exist. I'll explain why in a minute. But for now, just enjoy the freedom. Don't have to even check about a second one. So bring the B over here. And we say, okay, that's angle B. That's 38.376 degrees. Okay, so now we got all the sides. We got all the angles but one. How do we find the last angle? Law of sines, law of cosines? No, just add them and subtract from 180, right? That's all we're going to do for the last one. Just add them and subtract from 180. So let's do that.
96.624.
What it is?
Does it want the angle rounded to a certain number?
I think it wants whole number. I'll check that in just a minute for the angles and one decimal place for the sides, I think. Yeah, it's on the screen, huh? Round the nearest degree. Yeah, so for the degrees, it wants just what I was saying, the whole number degree. For the sides, it wants one decimal place. It wants one decimal place for the sides, whole degree for the angles. Yeah. So how'd we get there? But remember, along the way, you've got to use like 3 places, even though the final answer we're going to round more strictly. So anyway, yeah, how did Chanel just get that answer? She just took, so for angle C, she just took 180.
Minus angle A, minus angle B.
Yeah, just minus the 45 minus the 38.376, right? Because the total's got to be 180 minus the other 2. And that's how she got the 96.624. And so then we round it. So that's going to be 97, huh? So we'll round that one to 97. We'll round the other one to 38. 38. And the side, they want this side to be what? 5.7. And there we go. There's all the answers they want. Is that good? Is that making sense? So we found everything. Yeah, awesome.
I missed it really quick. I was looking down. How did you get the
Don't ever look down. No, I'm just kidding. What's that?
Just rounded it up.
How to get, what's that?
The 5.7.
Oh, yeah, I just took the 5.695 and I rounded. Yeah, they want me to round to one decimal place. Yeah, so whenever you round, you circle the place. They want you to stop one decimal place, so you look 1 to the right, and that rounds to 5.7.
Okay,
That's the old number we found.
Okay.
Yeah, that's the number we got somewhere. Oh, back here. Yeah, when we first did law of cosines. I just rounded it at the very end.
I was wondering, it just seemed like it came out of nowhere.
Yeah, it looked like it's brand new. Yeah, no, that's that old number for law of cosines, yeah. Good, other questions on that? Is that making sense? So let me write out for you those steps that we just did. So for side angle side, that means 2 sides angle in between. That's what we just did. That's how the problem started, huh? It was right. They see how they gave me two sides and the angle in between. That's one. Basically, there's going to be two setups today. There's two situations in which we have to have law of cosines that law of sines won't handle. Everything else law of sines will handle. That is sine angle side, and the other one we're going to see in just a minute is when they give me all three sides, no angles at all. Law of sines can't do that either because it's got to have angles. So law of cosines can handle that one too. So those are the two scenarios today is about. Those are the two scenarios in which you need law of cosines. Law of sines can't handle it. So first off, how do you do sine angle side? So you start, find the third side by law of cosines. That's what we did, right? Law of cosines, a squared is b squared plus c squared minus 2bc cosine a, or whatever, setup you have. So that's first. Second, so what do you do after you find the third side? Now you have all three sides. Then you use law of sines, right? That's what we saw. Y'all with me? But here's where I want to be a little more specific with you. So we're talking about the other two sides. Pick, how do I say it? Use, or don't use. Yeah, how about don't use? Do not use largest side. Well, here. I'm not doing that very clearly. Let's say, now use law of sines for smallest and medium sides. For smallest and medium sides. Wait, is that true? No. I'm sorry. I'm not saying this very clearly. Because it could be your largest is already involved in that. Now use law of sines. Pick the smaller side. Or use the smaller side. How about that? Use the smaller side. Why? Why am I making a big deal out of this? So use the smaller side. And then third angle by subtraction. By subtraction from 180 degrees. So there we go. Those are the three steps we just did, huh? And I'll explain, give some reasons why. Let me let you copy that down, and then I'll talk about why. All right, so step one, use the law of cosines. When you have sine angle side, use law of cosines, get the third side. Then step two, move to law of sines. But when you do, make sure you're using the smaller side. And then finally, just find the other one by subtraction. Now, why? Why do we have to use the smaller side? Because we want to avoid that whole difficulty where we, had to worry about the second triangle. Are there two triangle options, that whole thing? So I'll explain why. If you don't get all the intricacies of why, it's not a big deal. As long as you just use the smaller one, you'll always be good. But here's the deal. If you remember, why did we have that second triangle option? Because remember how the signs go. All students take calculus. So if you have something like sine of angle whatever B is coming out to be 0.3624 or whatever, and you're trying to find angle B, that could actually be two places, couldn't it? That could be somewhere here between 0 and 90 degrees, because in the first quadrant, sine is positive. They're all positive. And in the second quadrant, sine is also positive. So sine of that angle could be this positive number somewhere between 90 and 180 as well. So there's going to be an angle here between 90 and 180. There's going to be an angle in the first quadrant less than 90, right? There's going to be two options. Now, they didn't always work in the triangles. We would test those out. But there were two options. So notice with me, the second option is always in the second quadrant. and thus it's bigger than 90. The second option is between 90 and 180. It's more than a right angle. That means, right? You guys with me? So bless you. The only time we have to worry about the second option is when the second angle is more than 90. Now, what does that mean about a triangle? If I say, hey, I've got this triangle, and one of my angles, like this one, this looks like 100, a little bit more than 90. One of my angles is more than 90. Well, what does that mean about the other two angles? If one of them's using up more than 90, and there's only 180 total, could there be another one more than 90? No, there's only one more than 90. You couldn't have two more than 90. That'd be more than 180 already, right? There's only 180 total in every triangle. So my point is, if you have one angle in the second quadrant more than 90, he's the only one. Okay, so what? Well, that means he's the biggest one. If you have one angle more than 90 in a triangle, there's not another one. Can't have two of them more than 90. That'd be more than 180. So he's the biggest one, that means. There's nobody else more than 90, which means across from him is the biggest side. Remember, across from the smallest angle is the smallest side, medium, largest, largest. So if you have an angle more than 90, then he's the biggest angle, and across from him is the biggest side. Okay, so what? So you only have to worry about that second quadrant issue when you're dealing with the biggest side. You see, he's the only side that could have an angle across from him more than 90 in the second quadrant. The other option thing. Only the biggest side could have that issue. So if we just make sure we're never dealing with the biggest side, then we'll never have to worry about that other option. That's the reason. So that's why I said back here, use the smaller side. As long as you're not using the very biggest side of the triangle, then there's no way the angle across from it could be more than 90. There can only be one of those, if there's any. There could only be one, and that's got to be across from the biggest side. So if you're dealing with a smaller, then if you're dealing with some side that's not the biggest, then you for sure the angle across from you is less than 90. For sure it's in the first quadrant. For sure we don't have to worry about the other option. So that's the deal. It's going to be the same thing when we get to the second thing for side. They're always going to have a plan by which we don't worry about the second option. Generally, the plan is make sure you're always dealing with a smaller side, and you won't have to worry about it. No way to avoid it. Monday, with law of sines, we had to worry about it.
Okay, so you have to use it with the law of sines?
With law of sines, you have to, yeah. Because if they just give you a setup, if they just give you a triangle, and they just tell you, here's the side, and that's all you got. That's 17. It's the biggest side, or I don't even know what it is. Maybe there's not even a picture. Yeah, and then I don't have any choice. They gave me that side. I got to deal with that side. But with law of cosines, after using law of cosines, we'll have options because we just use law of cosines. So we'll be able to choose. So we'll be able to avoid that problem. All right. So if you didn't get every detail there, don't worry about it. Just always pick the smaller side. You'll be good. All right. Let's try it. So now giving me that information, they basically want me to find everything else. So if it helps you, you can draw a picture. You want to draw a picture? This is all they give you, is just exactly this. And they say, what they say is solve the triangle, which means find all the sides and all the angles. A picture might help. So let me go ahead and draw a picture here. So this is capital A, capital B, capital C. And across from A is little a, across from B is little b, across from C is little c. Right? Angles and the sides across from them. So little a is 2. Little b is 7. Capital C is 50 degrees. So do you see that they're giving me angle side information? Right? They're giving me two sides and the angle in between, aren't they? So you know what to do. Go ahead and use the law of cosines for step 1. What formula, which side are we looking for? C, so we're going to write, so step 1, law of cosines, so C squared, because that's the side we want, is the other 2, looks like the Pythagorean at first, minus, it's always minus an adjustment, subtraction 2 AB cosine of what?
C.
C. It's always the one across. Yeah. All right. All right. So A squared, B squared. So 2 squared plus 7 squared minus 2 times 2 times 7 times cosine 50. And then, so, let's see. Plus 9 minus. I'm getting 35.0019. Maybe we'll make it 2. It's fine if you did 001. It's probably fine. Anyways, square root it. Or I could just do the square root of the answer on my screen there. Yeah, I use the answer button as much as I possibly can. It's convenient and it's more accurate. So I'm getting C equals 5.916. So 5.916. So we got C. 5.916. We can round it later. 5.9, right? That's how they're going to want later, but don't round it right now. Okay, now, so that's step 1, law of cosines. What do we do now? Step 2, law of sines. Law of sines. Okay, and when I use law, now when I'm going to use laws, of course I'm going to use C with C. There's no choice there, right? I've got to, because that's the only complete pair, angle and side across from it, right? Got to use that. So let me just write that down for sure. Going to use that. 5.916 over sine, law of sines now, of 50 degrees equals. Now, what other pair? Presley.
Just a quick question.
Yeah.
Are they ever going to pair it up with the largest size like that? Like where we have to use, the one that we have to use, are they going to ever?
Oh, it could be, but that's actually not a problem. Yeah. So I see your question, Presley. Like what if this was? You're saying like what if C was like 9.3 or something? It was the biggest side. Yeah, it's actually fine, and you would use that because that's what you got. You got to use it, and you think, well, yeah, but what about the problem? Well, remember what is the problem? The nature of the problem is 2 options. We know this angle across, so it's not a problem. It's only when it's unknown. And we're like, oh, should we do this one or that one? How do we know? If you're always using the side that's not the biggest, then it's always the smaller one. Whereas, so it doesn't matter if you already know the angle. You know the angle. It's not a problem. Good question. So all we have to worry about, so when we're looking, so everybody good with, for sure we're going to use the one we've got. That's why we found it. The C with the C. Going to use that because that's the only angle and side pair complete we have. Now, am I going to do the B next or the A next? The A. See, the problem is if I used the B may, see how the B is the biggest side? Then the angle across from it might be more than 90. It might not. I don't know. The fact is, if I did law of sines, I wouldn't know. And the 2 options would confuse me. So that's why we don't do B. We'd have to worry about the 2 options thing and all that because that's the biggest side. It might have an angle more than 90 across from it. But no way A does. Oops, I just erased it. No way A does because A is not the biggest side. There's no way the angle across from A could be more than 90. No way, because then there'd have to, because B's bigger than A, and then B'd have to be more than 90. Then you'd have 2 more than 90. That can't be. Making more sense, the logic here? So as long as we use something that's not the biggest side, we know that the answer we get out of sine inverse, boom, that's just the answer for sure. No second options to worry about. All right, so let's do it. So here we go. So I'm going to go A over sine A, like that, right? I'm going to do A instead of B. Everybody with me? So again, you don't have to understand every detail, just don't use the biggest side. And you'll be safe. So I'm doing A instead of B. And I'll get B in the end by subtraction. That's how I'll find the B. And so then you cross multiply. Diagonal, diagonal. And so I'll get 5.916 sine A is 2 sine 50. Diagonal, diagonal. And then I want to get sine A alone. So I'm going to come in here and divide by 5.916. Cancels out. So bring it up here. Sine of A equals, I have no idea, 2 sine 50. 2 sine 50 divided by 5.9116 is 0.2589. It goes on and on. And then sine inverse on both sides. That's what gets rid of the sine, right? So that we have A. So angle A is sine inverse. Whoops, I just cleared it off my calculator there. So sine inverse of 0.2589. I'm getting 15.00. 005, I guess, for whatever, degrees. So I got angle A. Angle A is 15.005. So angle A. Is that what you guys are getting?
Yeah.
15.004 or 5. It doesn't matter if you say it's 4 or 5, whatever. That far down the line, the decimals don't really matter. 15.005 degrees. Finally, let's get angle B. How are we getting angle B? By subtraction from 180. You good there? So that's step 3. Maybe I'll squeeze it in up here. So step 3 is 180 minus, so B, this is how to find angle B. B is 180 minus 50 minus 15.005 or 4, whatever. B will be 180 minus 50 minus. I'm getting 114.995. So now it's rounding time. They want me to round that to 115 degrees, huh? 115. The A rounds to 15, and the C down there 5.9. Hey, look at that. B did turn out to be more than 90, didn't it? You see that? It would have been a problem if we had tried to do B early on. We would have got actually the other answer at first and not known which one was right. So, yeah. See how the biggest side, B, is across from the biggest angle, and the medium side, C is the medium angle, 50 degrees is the medium, is across from the medium side length, 5.9, and the smallest angle, 15, is across from the smallest side. How it always works out.
That way they say start off small.
Okay, that'll work. Start off small. Yeah, we'll just use that old saying. Yeah, start off small. Good. I like that. Kind of stuff sticks in people's minds. Good. All right. Good on that? Questions? We're going to change to the other situation now. So that's side, angle, side. Those are the steps for side, angle, side. Law of cosines first, then law of sines, then by subtraction, always starting off small on the sides. All right. Now, the other scenarios I already told you. They're giving me the 3 sides, no angles at all. 3 sides, no angles at all. Let me draw a little picture of the thing. So capital A, capital B, capital C, and little a across from A, little b across from B, little c across from C. So they're telling me little a is 7, little b is 5, little c is 3. All right, so I need to find all 3 angles. We've got all the sides, we just need the angles. So why can't I just use law of sines? Do you see why we need the law of cosines for this as well? Why they didn't give us this problem 2 days ago when we were doing the law of sines? We couldn't have handled it, right? Because again, we have no complete ratio. Like what if you tried? What if you said, okay, I'll do it with law of sines? What? Don't write this down. This won't work. But if you said, I'll do, this over this. Okay, 7 over sine A, and then, B over B or whatever. So then 5 over sine B. You see, you have 2 letters again. How are you going to solve? You got 2 letters. Not going to work. So law of sines doesn't work in this situation either. So this is the one other situation. Now, after this, you can handle any triangle. Because law of sines handles all the rest. Law of cosines handles side, angle, side. And this is side, side, side. So what do? What is the game plan? Let me write out the game plan for you. And then I'll kind of explain why afterwards. So for side solving, side, 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 they give you all three sides. So before I gave you instructions for side, angle, side, right there, side, angle, side, right? Now it's side, side, side. All three sides. So how do you do it? Step one, start, the saying's not going to work here. Start with the largest side. And that might seem like, what? Well, you changed your plan. Well, it's because we're still, go big. I guess there's a saying for everyone. But how do you know which one's which? Start with the largest side for, well, here, I should write that better. Let me start it this way. Sorry. Keep changing my mind. Law of cosines. We're starting with law of cosines. Largest side. Now, why do you think with law of cosines, I start with largest side? So that when I get to law of sines next, I've already done the largest side and I don't have to worry about it. Does that make sense? So it's really only the law of sines that has a problem. So how about sines small? That's the best I can do. Whenever you use law of sines, you want to make sure you're using something small. Yeah. Start off small with the law of sines. Cosines has no problem. Now why? I haven't given you. Well, why does law of cosines not have an issue? It's because if somebody says, hey, cosine of angle whatever B is 0.3829, and then I hit inverse cosine, where could that be? What quadrants could that be? Where's cosine positive? All students, take calculus. First, of course, they're all positive in the first. And the fourth. What kind of angles are in the fourth? This is 90, 180, 270 to 360. Could you have an angle in a triangle that's between 270 and 360? It's more than 270? There's only 180 total in a triangle. How could one of the angles be more than 270? Never gonna happen. So you never need to worry about the other option for law of cosines because it's fourth quadrant. Never going to happen. So that's why law of cosines is not a problem for us. It doesn't have the same issue that law of sines does when we hit inverse sine or inverse. It's all about that inverse button, right? Everybody with me on that? It's when you hit inverse sine or inverse cosine that you're like, oh, but what about the other option? For inverse sine, you got to worry about it if you're using the largest side. Law of cosines, never a problem. That other option, the other place cosine is positive, fourth quadrant, that can't ever be inside of a triangle. An angle bigger than 270. So that's why we just let law of cosines handle the largest side. Cosine handles the heavy lifting, and then sine can do the rest without a problem. So that's what we do. So same kind of thing. You start with law of cosines, largest sine, and then you do law of sines, and then subtract. So and when I say law of sines, it's either one, because you've already used the largest at this point. So who cares which of the other two you use? See the game plan? So the issue, so what I like, it's hard for me, I don't have very good memory, so I don't do very good at memorizing. You can write all this in your 3x5 card. But I like one concept that just helps me get it. The concept is this: never use the biggest side with law of sines. That's what all these things are doing, is avoiding the biggest side with law of sines. That's where you can get into trouble. So just remember that. In anything you're doing, if you're about to do law of sines, just make sure you're not dealing with the biggest side, and you're good. You never have to worry about the other option. That's what all of them are about. All right, let's do it. So step number one, going to do law of cosines. And now, which side should I do for law of cosines? Yeah, the biggest, right? You can let cosines do the heavy lifting. So start with A, the biggest side. And then when I get to law of sines, I won't even have to think about it. So here we go. So he's going to be A squared is B. So it's like the Pythagorean with an adjustment. Minus 2BC cosine A. Right? It's always the one across, right? A squared ends with cosine A. All right, let's get it. So that's going to be 5 squared plus 3 squared minus 2 times 5 times 3. Cosine of capital A, which I have no idea. That's what I'm trying to find. Oh, and I know the A. I should fill in the A. Yes, we know A. It's no mystery. Yeah, there we go.
Oh boy.
So we got to solve that for A. So this would be 49 is 25 plus 9 minus, this will be 30. Cosine A, got all those numbers there, okay? And this will be 49 is, what's that, 34 minus 30 cosine A. Trying to solve. Can I subtract? Wait, everybody caught up with me there? Can I subtract these two? 34 minus 30 make it 4? No, because that one's got a cosine. It's like unlike terms. It's like 34 minus 30x or something. You know, they're unlike. Can't do that. Trying to solve cosine A. What do? I want to get this piece alone first. He's like a big X. Think of him as a big X. You know, you want to solve for him. So what do I do next? Exactly. Subtract that 34. This is gone. And we get, what's that, 15 is minus 30 cosine A. Still trying to get that cosine A alone. What do I do next to get that cosine A alone? Divide. Yeah, because this minus 30 is right up against the cosine multiplied, huh? So got to divide it. I can't add the 30. It's not subtracted. It's multiplied, huh? So got to divide it. So divide by minus 30. Divide by minus 30. Cancels out. Bring it up here. So cosine of A equals, what is that, minus a half? Minus 0.5 on that. And then how do we get the A now? Cosine inverse. Cosine inverse. On both sides. So it cancels out here. And A will be whatever your calculator says. 120 degrees. Getting that for angle A. So I'm going to write that in 120, nice and clean, no decimals or anything. So that's nice. Notice that's the biggest angle, isn't it? It's got to be the biggest angle because it's more than 90. There can't be another one more than 90. The other two have to make 60 total, don't they?
Well, that and the A is the larger number.
Right. So I'm just connecting both ideas in your mind. Biggest side, biggest angle. So now, so that's all step one, law of sines. Found one of the angles. And so now step two, what are we going to do?
Now that you have a ratio, now that you can find the other side.
Now we go to law of sines and now that we have a ratio, exactly. Now that we have an angle and the side across from it. That's one of my fractions, and then you can do either one next, doesn't matter at all. So I'm going to go 7 over sine 120. I'll just do the smallest one because I'm in that habit. I'll do C with C. 3 over sine of angle C. But you could have done B over B. Doesn't matter because we've already done the biggest side. So it's not a problem. We know law of sines is not going to have a problem with either one. So now cross multiply, diagonal, diagonal. 7 sine C is 3 sine 120. How do we solve for C there?
Just add and subtract. Add side A, side B.
Well, first divide by that 7, right? And then we'll. You're already there. Sine C, and so whatever the calculator says on that, 3 Sine 120 divided by 7. So I'm getting 0.3711 or 12, whatever, if you want to round it. And now hit sine inverse, huh? Sine inverse. Sine inverse. Cancels out here. C equals, just use your calculator, whatever's on the, use the answer button, sine inverse of the answer. I'm getting 21.787 or 6, whatever, degrees for angle C. So I got angle C, 21.787 degrees. And so finally we can get angle B. Step 3, angle B is 180 minus 120 minus 21.787 degrees. So there it is. I'm getting 38.213 degrees. And we're done. We were able to find all the angles by using law of cosines on the biggest side, and then law of sines for another side, and then subtraction from one angle. So that's it. Those are the two scenarios. Side angle side and side side side. Questions on that one? Does that make sense? Okay. So there we go. They're giving side side side. They're giving me all three sides. So we're going to begin. We always begin with law of cosines, then we go to law of sines. So you're going to start with law of cosines. Did I keep somebody's calculator? Oh, yeah, that's right. All right. Okay, yeah. So now, when we start with law of cosines here, so law of cosines. When we start with law of cosines, we're supposed to start with the biggest side, right? But they're tied. So use either one. Doesn't matter.
And that would just mean that they would get the same angle on
Exactly. So you realize what this means. This is going to be a quicker problem. Because those two sides are the same, their angles across from them are going to be the same as well. Once we found one of them, we found them both. And then you have two, and just subtract from 180 and you're done. We're not even going to go to law of sines on this one. You getting the idea? Do law of cosines, get that one angle, the other one's the same, then you get two, the third one's from subtract from 180. That's why I didn't want to start here. This one's artificially easy. I wanted to show you the hardest case first. All right, so law of cosines. So give it a try. So start with B or C. Maybe I'll just start with B. B squared. You can start with C. It's just as good. They're both, start with the biggest, because law of cosines can handle it. Okay, so B squared is Pythagorean, kind of like Pythagorean, minus 2AC cosine of, what cosine of which one? The B, capital B, the one across, huh? Like that. Law of cosines. Okay, let's plug in what we got. This is 6 squared, 4 squared, C squared is also 6 squared, minus 2 times 4 times 6 cosine B. So that's 36 is 16 plus 36 minus something, 48, cosine B. And then that's 36 is 52 minus 48 cosine B. Okay, so we're trying to solve there for cosine B, right? What do we do next? Subtract that 52, yeah. Let's go on, so then that's some negative number. Is that minus 16? Yeah, equals minus 48 cosine B. And then to finish getting B alone, cosine B alone, divide by minus 48. Like that. These cancel. Bring it up here. And we get, what is that going to be? Yeah, that's 1/3. So your calculator would be 0.3. It's fine if you have decimals or fractions, whatever. Is cosine B. Is that what y'all got? To that point. Good, positive, right? 0.33 because two negatives make positive. Okay, now how do we finish getting B? Inverse cosine. That's what will get rid of that cosine from the front. So cosine inverse and cosine inverse cancels, and so we get some kind of an answer here. Let's see. So I'm getting I'm getting 70.528. 528. You could round it to 9, whatever. Doesn't once you're 3 places down, doesn't really matter. 70.528. You guys getting that? So that is angle B. So 70.528 or 529, whatever. Now, if that's across from side B, side C is the same as B, so the angle across from it's got to be the same. Remember how that works? What's this called, a triangle where two sides are the same? Anybody know those words? I'm not going to quiz you on the words. Equilateral is all three are the same. Isosceles. That's it. Yeah, this one's isosceles. Means two of them are the same. Anyway, don't need to know that. 70.528. So those have got to be the same, right? Because the two sides are the same, the angles across are the same. So now we've only got one angle left to subtract from 180. I don't need to mess around with law of sines or anything else. Just say angle A is 180 minus 70.528 minus another 70.528. So I'm just going to go times 2 and then 180 minus answer. And I'm getting... So the way I handle it is I just multiplied it by 2 on my calculator and then did 180 minus the answer. I'm getting 38.942 degrees. 38.942 degrees. And we're done.
Does it want those degrees in the whole numbers?
Yeah, so you have to round them all to whole numbers. So this would actually end up being 39 degrees. This would be 71. Both of them would be 71 degrees. And this also is 71 degrees.
That adds up to 181.
Yeah, isn't that funny? I was going to point that out too. Yeah, if you add those three up, it actually adds up to 181. That's why you don't round early on, because it's all because of rounding that they're adding up to be too much. Now, you see what I mean? I messed up the thing here. If I'd rounded that 70 number earlier, the 70.5, it would have rounded to 71, huh? And then if I would have thought, okay, two of them are 71, that would have been 142. Subtract from 180, that would have only left 38 for the other one. But the other one actually rounds closer to 39. You would have got the wrong answer. That's why I'm pointing out don't round to the end. So yeah, it's kind of funny, huh? When the three are all rounded, they actually come up to more than 180. That's because of the rounding issues. So don't round until the end. There really is just exactly 180 in that triangle, but rounding makes it look different. We good with those? All right, law of sines, law of cosines. Question number 6. Let me draw the triangle for us. So we got capital, here we go. Capital A, capital B, capital C, little a is 4, little c is 4, little b is 4. All right, so let's try that one. So number 6. So what are we going to use on this one? Yeah. Jamin? Am I saying your name right? Jamin? Yeah, what are we going to use?
Me?
Oh, sorry. Jamin? Yeah. Exactly. Just use common. We don't need law of sines and cosines. Yeah, all the sides are the same, huh? Like Kevin was saying earlier, that's an equilateral triangle. All the sides are the same, so that means all the angles have to be the same. Right? So if all three angles are the same, and there's 180 total in a triangle, and they're all three the same, just divide by 3. If I said, hey, I got 3 numbers, they make 180, they're all the same. Thank you. Then you get 60 degrees. They're all 60. Done. So I don't want you to waste any time on that problem. Good? I mean, you could do law of sines and cosines and everything, and it would tell you 60. Does that make sense? Because all the sides are the same, all the angles have to be equal. Remember, just like the last one, when we had 2 sides the same, 6 and 6, then those 2 angles across had to be the same. Here we have all 3 sides the same, so all 3 angles have to be equal, and they total 180, so they're all 60. Done. Next problem. Did you see it? There it is. I got in the book. Herons formula.
Spelling.
Little spelling issue. They misspelled my name. But yeah, mine is the official spelling. There's it's Herons formula. Mine's official. What do I mean by mine's official? Mine is official in Germany. In Germany. It's a German name. I don't think I'm being too prideful to say that my name is written in more places in Germany than any other name. Tied with one other name. Tied. Most famous name as far as names written on things. My name. I'm not exaggerating. You know what my name means? Yeah, it means men. It's on all the bathrooms. Yeah. so the women with Damen, which means women, that's equal. The men and women said, yeah, it's the men's room. I had one semester, start of fall, philosophy class at Cal Poly. I remember the professor was doing the names on the first day of the roll. He got to my name, Heron, here, and he stopped, he looked at my name, he said, it was the fall, he'd just been over the summer traveling. He said, this summer, I was traveling in Germany. You know, your name is on all the bathrooms. I'm like, yeah, I've heard. Yeah. All right, so Heron's formula, what is it? It's a little formula for finding the area given 3 sides. It's kind of a surprising little thing. Like, if you have some triangle, we got a special area formula last time where we had, what was it, a couple sides at an angle or something? Yeah, 2 sides at an angle. And the normal area formula is a half base times height. That's the normal area formula, half times base times height. But we're not going to, that's about the only one we have. And then the weird one we got last time for 1/2, 2 sides, side of the angle between. Well, this is a totally different one. If you have 2 sides, if you have all 3 sides, there's a way of finding the area, which is kind of surprising. All the space in the middle of a triangle. Like, how could you find all the space just by knowing the lengths of the sides? Don't you have to have something in the middle? Surprising, you can do it. Here, I'll just give it to you. Here it is. So, well, first off, you got to start with, how do they write it? P for perimeter? Do they use S? They use something a little weird. They use S. Okay, I'll use S. I'll use their letter. So, and S means perimeter. No, it's half perimeter. That's right. Okay, so S equals, I always forget it. I should remember my own formula. A plus B plus C. It's really not used very often. There'll be like one question on the exam. It's not that big of a deal. So S equals 1/2. That's half the perimeter, right? Half the 3 sides added up. So they use this thing called S, which is half the perimeter, and then the area is the square root of S. My S's don't look so good. S times S minus A times S minus B times S minus C. There it is. So just put that thing in your 3x5 card. There'll be one question on the exam, next exam on it. That's all. There's just 2 homework problems. It's not that important. We need to get on number 9. 9's harder with the thing. So let's crank this out quick. Yeah, question?
Worry about the S equals half?
Yeah, so I'll crank it out now.
Oh, okay.
Yeah, no, I'll do it. I just want to give, so there's what you want to put in your 3x5 card. So let's actually crank it out now. So S will be, so what is it? It's a half times 4 plus 4 plus 1. What's that? Half of 9, 4.5. Good so far? So I'm just cranking it out now. So there's the formula in red. Now I'm cranking it out in the purple there. So it's half of the 3 sides added, half of the perimeter, 4.5 there, right? Because if you add up the 3 sides of the triangle, that's the perimeter, and so S is half the perimeter,
Okay.
4.5, and then you plug into the area formula.
I see what you're doing.
So the area will be the square root of S, so you start with S, which is our 4.5, 4.5 times S minus A. So 4.5 minus the first side, which is 4, times, next comes S, 4.5, minus the B, another 4. And the third one is S, again, 4.5 minus the third side, which is 1, C, which is 1. There it is. So then, what's that going to be? I'll bring it over here. The area, the space in the middle of the triangle, is going to be square root of 4.5 times 4.5 minus 4. Bless you.
So it's 1.5.
Isn't it just 0.5, right?
Oh, yeah.
And 4.5 minus 4.
0.5.
0.5, right? $4.50 minus $4, you know. And then over here, $4.50 minus a buck. 350. And then just hit the buttons on your calculator. Or you could have done it even on the early. You could use calculator at any stage you want there. So square root of 5 times 1.98. I don't know how far they want me to round. What do they say? Nearest square. So 1.9. They want me to just say 2. They just say go to the nearest whole number. So 1.98 is the area which rounds to 2. Is that coming out okay for you? Making sense? Can you read it between all of them? Maybe I should have put it on a fresh screen there. Can you read all that okay? Questions on that?
I did from next year.
Did you? Let's see.
When I did the area inside the square root.
Yeah? Let me see. Okay. All right, so a couple things we got to get straight. We got to be really clear on these direction things. Kind of nice. I always like seeing something a second time. Math and science is always super hard for me first time. Second time, it starts to make more sense. So this is our second time with these angle direction things. Hopefully you'll have that experience as well. But it gets a little easier. So let me draw a big old axis system. Just making up the axis system to help us. Okay, so south. So let's start in the middle. Did they start at the same spot? 2 ships leave a harbor at the same time. Yeah, so they're starting at the same harbor, leaving at the same time. So I'm going to start them both at the origin. I'm making up the axis system for my convenience. I'll start them right at the origin. Okay, so let's head the first one south 13 degrees west. South 13 west. Do you remember how that works? Let me remind you about that. So you do the first thing first. So south, well, remember this is north, south, right? You remember all that? East, west. So it's headed south. So first you just go straight south, but it's not straight south. It's south, but it's 13 to the west of that. So it's a little bit, this is 13 degrees to the west of straight south. Sorry, I'm not doing that very neatly. There we go. 13 degrees to the west of straight south. Does that make sense? South, but 13 west. So that's the direction of the first ship. Now, so let's just put him, whoops, he's moving on me. Let's just put the first ship right here. Okay, now can you do the second ship in red? Or, I mean, just what, in mine it's in red. So do this, like, draw an arrow in the right spot for that one. So north, 75 east. So we're headed north, but not straight north, not straight north, huh? 75 to the east. That's almost 90. That's almost all the way to the east. So that would be like, sort of like that, huh? 75. Just like this one is 13 to the west. This one is so it's not really straight north. Let me get rid of that. It's not straight north. But it's north 75 east. So there it is. There's the second ship. Make it a little shorter. So there's the second ship. Is that bearing stuff making good sense now? So you always do the first thing they give you, like south or north or whatever, but then go west or east as they tell you. South, 13 west, north, but 75 east. Which is almost 90, right? Almost all the way down to the east thing there. Okay, so now, okay, great. So I got those. So how far do they go? Well, it's for 2 hours, huh? They travel for 2 hours.
You just multiply the mile per hour by 2.
Perfect, yeah. So if I said, hey, I went out and I drove my car at 15 miles an hour. I am getting older. I am driving a little slower now. So I go out and drive my car at 15 miles an hour for 2 hours. How far will I go? Not very far, huh? Yeah, 15 miles per hour means you cover 15 miles every hour, right? So times 2 would be 30 miles, huh? You with me? 15 miles the first hour, 15 miles the second hour. I'd only get 30 miles in 2 hours. So that means the purple thing, the length of his trip is 30. The length of that arrow, he got 30 miles, didn't he? How about the red arrow? How far did he get?
22.
Yeah, because he only went 11 miles an hour times 2 hours. He's only 22. So, to make it look better, I should make the red arrow a little shorter than the purple arrow. You don't have to. It doesn't really matter a lot. It'll all be okay, but I'd like it to be a little more helpful. So make this a little longer. Anyway, there we go. So the purple arrow is a length of 30, 2 times 15. The red arrow is a length of 22, 2 times 11. Okay, so the question is now, what is the question? How far apart are they? Well, ship 1 is down here, this dot. He went, that away for 30 miles. The red one went up and to the right for 22 miles. So after 2 hours, it's like snapshot. They do that all the time in physics. They'll be like, my daughter and I are always talking about that at the table. We're doing a problem. I'm trying to get her to think that way. It's been challenging for her to think that way. Like the things will be in motion, the ships and the planes and the things sliding on tables. And then they'll go right at 2 seconds. How fast is the thing moving? And I'll go, so honey, see, it's like a video. It's in motion, but then freeze frame, right when they say at 2 seconds. Right then, you got to freeze the video. Kind of think that way. So that's what's happening with these ships. So as they're moving, freeze frame at 2 hours. Right then, they freeze the video. How far apart are they? So wouldn't that be just a line that goes from there to there? Mm-hmm. Like that? That's the distance at that. If you freeze the video, these ships are in motion, right? The ships are moving, but you freeze the video at 2 hours, right at that instant. How far apart are the ships? What's the distance of the line directly connecting those two?
So is that kind of like last time's homework with the shot put thing, like the distance between the angles?
Yeah. Yeah, distance, yeah, straight arrow between two things. Yeah, right, yeah, distance between two. Yeah, so what we really have is a triangle. After all that drawing and calculating miles per hour and everything, we have a triangle. And we have, let me move this over so it's a little more clear. This side's 22, this side's 30. I don't know this side.
We kind of know that, or we can figure out the angle.
Yeah, and if we can get one of the angles, then we can use law of, we're in the law of cosines section. No surprise, we're going to end up using law of cosines, huh? So yeah, can we, right on Kevin, can we somehow figure out like this angle right here? What's it going to be?
Well, we have 13 and 75.
Yeah. Yeah, you guys are thinking right. Let me draw it really clear here so we can really focus in. So that's, yeah. So let's take it piece by piece. If from here to here is 75, then what is this little opening right here? 15, yeah, because 90, right, minus 75 is 15. This has to be 15 right there. Let's just piece it together. This part is clearly 90. It's a right angle, huh? And then this last part here
13.
is the direct 13. Add those three up, huh? We can write it here, 13. Yeah, so add those three up. So I'll put it maybe over here. So 15 degrees and 90 degrees and 13 degrees. Was it 118? So that means this whole angle here is 118. I'll put an arrow there. 118 degrees. Now I've got side, angle, side, law of cosines. Everybody see how I got those little angles? So the drawing is super important, isn't it? For physics, it always is. Getting that video and then freeze frame and getting a good picture. It's really important because all those angles matter. So, see how we got it? So 15 here, we subtract from 90. Then the 90. And this is 13. They directly gave us 13 west of south. So we add those three up. 118 degrees. So, with that in mind, I'm just going to go to a fresh screen with a nice clean picture. So, we're going to have a triangle 30, 22 with a 118 in the middle. So we have, like so. So it goes like this and like this. Sort of, maybe that's too much. So this is 30, 22, right? Yeah. And 118 in the middle, 118 degrees in the middle. And I want to call that X or D. How about D for distance? Whatever. Well, let's call it X. Whatever. That's the side we have to find. That's the distance between the two ships. So it's side, angle, side, which means we need law of cosines. Step 1. Law of cosines. So when we do the law of cosines, they're no longer called A, B, and C. We just have to use the general idea. So obviously we want the X. Let's start with that. X squared is going to equal to the other two sides. Either order, doesn't matter at all. You put the 22 first and the 30, whatever. So any side squared is the other two squared. It's like the Pythagorean kind of at first. But then it's minus 2 times one of the sides times the other side times the cosine, yeah, of the angle across from that side, huh? See how the X is across from the 118? Remember, that's how law of cosines always works? You're always using the side and the cosine of the angle across from it. So there it is. That should give us the answer. I have to square root it in the end. So 9. So I'm getting 2003.702 and then root it. I'm going to do square root of answer. Square root of answer. I'm getting 44.76. I don't know how far they want me to round. What'd they say? Round to the nearest tenth. So 44.8 miles. So those two ships would have to be 44.8 miles apart at that instant, at exactly 2 hours. Is that good? We got one more. We got 6 minutes. Let me see, get that last one for you. Questions I can answer. I don't want to move on too fast. Is that okay? So this will be on YouTube. It's all about that picture, isn't it? It's all about that, making that picture really carefully. Coming out. Good. All right, so here's number 10. Last one. We are at islands, kind of picture here. We are at island A, right there. And we want to go to island C, they said. So from A to C, here's C. So I want to go that way, right? From A to C. What bearing, if you're on a ship, you know, what bearing is that? So they want like the angle. They want the angle bearing. Now, how do you figure out an angle bearing? Well, basically the bearing is going to be straight north, but some amount east of north, isn't it? The answer is going to be north, some kind of degree, call it x degrees east. That's the way the answer is going to go. Is that making sense first off? Because we need to have memory. So the way bearings always work is you start with north or south. You don't start with east or west. They just made it up that way. They could have made it the other way. That's just what they did. So for bearings, they always do north or south first. We're obviously not going south. So we're going north, but not straight north, a certain amount east of north to head straight to island C. So really the whole problem comes down to, what is this angle here, x? Because this is east over here, and this is south and west. So what angle is this x here? That's what we have to figure out. What is that angle x? So how do I figure out that angle x? Well, basically, you should first figure out this angle in here. Call this one y or whatever. If you figure out this angle y and subtract from what? 90, because these two make 90. This is straight up, north and straight east. So if you figure out, say this is 60, then subtract from 90, that'll be 30, and we'll have our bearing. Does that make sense? It's all about finding this angle in the triangle, call it y. So how do we find that angle? Law of cosines. We got all three sides. We've got all three sides. Do the law of cosines. Find that angle. Subtract from 90. And it'll be north, that angle east. See the bearing? The bearing is straight north, but not pure north. A little east of north to head right to C. So, all right, let's do law of cosines. I'll move it over. What do we got? 18. So law of cosines, you'd start with, so for law of cosines, you start with the side across from the angle that you want. So it's going to be 24 squared is 18 squared plus 21 squared minus 2 times 18 times 21 times the cosine of angle y, which is across from the 24, right? Everybody see that? See how the 24 is across from the y? So there we go. Let's hit the buttons on our calculator. 24 squared, I'm getting 5. 76 is 18 squared. 324, 21 squared. 441 minus 2 times 18 times 21. 756 cosine of y. Is this making sense so far? So I'm doing law of cosines. Law of cosines, it's always about a side and the angle across from it. Kind of like law of sines. And then to finish solving here, what do we got? Add those up. 576 is 324 plus 441. 765 minus 756 cosine y, if you can read that. And then subtract 765. I'm getting negative 189 is negative 756 cosine y. Last step to solve, well, second to last step, then you got to divide by the minus 756. Boom. So cosine y equals 0.25, that's nice. 0.25. And so then we do inverse cosine. Inverse cosine cancels out. So y equals inverse cosine 75.52 degrees. You getting that? So angle y is 75.52 degrees. So then angle x is 90 degrees minus 75.52 degrees. So it's 14.48 degrees. So the heading should be north. I think they want you to round to one place. 14.5 degrees east. That, or the bearing. That's the bearing to go straight to island C. North, but 14.5 degrees east on that.